assignments do you get for each semester? You get 6. Okay, so let's finish up chapter 1. This section is on what this book calls the fundamental trig identity. Okay, can somebody remind us what an identity is? Talked about it before. You have some identities that I said you need to have memorized for next Wednesday. What's an identity? What's that? It's a formula, sort of. Okay, an identity is a fancy word that just means a true equation. Okay, it's a true equation. All right, so it's about the fundamental trig identity and something called reference angles. If you've been paying attention and you've done what I asked you to do, get things memorized on the unit circle, think about it the right way, all that sort of stuff, this is going to be very easy. Okay, inverse trig functions how do we fill in this blank? Take ratios. And they give us angles in return. What's the range for sine inverse? So in other words, if we put a ratio in there, it's going to give us an angle back. What type of angles? What is the range of angles that it gives us? David?
Negative 90 degrees greater than a angle greater than 90 degrees.
Okay, so he's talking about doing it like this. That's fine. Or you can write it down in interval notation from negative 90 to 90. Either way is okay. What's the range for cosine inverse? Okay, that's going to be 0 to 180 degrees. And what's the range for tangent inverse? Okay, that is negative 90 to 90. Okay? And let's see, that actually has round brackets on there. Okay, we won't make a big deal of that right now, but we will later on. So if we give sine inverse a ratio, it will give us an angle between negative 90 and 90. Okay, if you wanted to answer in radians, this would be negative pi halves and pi halves. Okay. Or we could think of it in terms of quadrants. It's in this quadrant right here or this quadrant right here. In quadrant 1 or 4. Okay? And then it says, right, sine alpha, cosine alpha in terms of x's, y's, and r's. So the sine of alpha is, what over what again? Y over r. And then cosine of alpha is x over r. Very good. Okay, now, if you have that stuff memorized, you're actually going to be you've got a couple things memorized for the test already. And then it says, last part here, what is the easiest way to write the sine of alpha times the sine of alpha?
The sine of alpha squared.
Sine of alpha squared. So you could write it like this, sine of alpha quantity squared. But because we run into this so often, whenever we take a trig function and we raise it to a power, we don't want to put the parentheses. So what we do is we do this. We write sine squared alpha. Now remember, a trig function doesn't mean anything unless you put an angle into it. So this doesn't have any meaning, and neither does this. Okay? Even though we say sine squared alpha, it literally means this. Don't forget that if you were actually going to do an operation for that, we'd put whatever that ratio was in parentheses, we'd put the square on the outside, and then we'd do the math on that. Okay? Any questions? Sure? Because we're going to use these ideas in the lecture today. Okay, let's take a look. So again, going back to 1.1, if we have a point on the xy plane, we call the distance from the origin the radius, and we represent it with the letter r. So if this is our point xy on the coordinate plane, the distance from that point back to the origin, we call the radius. Okay, and that's because we have this circle going around and all that sort of stuff. Okay, if we form a right triangle with the x-axis, and again it's always with the x-axis, we can use the Pythagorean theorem to write an equation that relates the x, the y, and the r. So if this is the xy pair, this is an x, this is a y. If we then focus on just the right triangle, if I take the two legs, square those and add them together, So this is going to be x squared plus y squared equals r squared. You okay with that? Then we can use that equation and some algebra to derive an interesting identity. So here's what we're going to do. We're going to take this, and we're just going to play around with it. We're going to see if we can come up with some identity involving trigs. Could we go from x's, y's, and r's to sines and cosines or tangents or something like that? So I'm going to take this and I'm going to divide everything by r squared. Now, what I've done here is basically this: x squared plus y squared equals r squared. Divide that side by r squared, and then broke this into two pieces using the properties for fractions. Everybody okay with that? Okay, I'm then going to take this and I'm going to write this as x over r quantity squared. And I'm going to write this as y over r quantity squared. And what am I going to do with this? Just make it equal to 1. Now, does any part of this look familiar? Yeah. This is cosine of the angle right here, and this is sine of the angle right here. So this would be, cosine of alpha, quantity squared, sine of alpha, quantity squared, equals 1.
It's also the equation for a circle, isn't it?
This?
Yeah.
Not quite. Not quite. It's close. Good thinking. Okay, again, we normally don't write it like this, so I'm going to write cosine squared alpha plus sine squared alpha equals 1. Okay, and this right here is what the book calls a fundamental trig identity. Now, the problem with this is, I mean, we normally just grab this one. We think in terms of x's, then y's. So we wrote it down like this. We did the algebra like this, and we ended up with cosine squared plus cosine squared of alpha plus the sine squared of alpha equals 1. We normally say sine first. So if you ever see this, it's going to be written like this. So this is the fundamental trig identity. So sine squared alpha plus cosine squared alpha equals 1. Now, there's nothing really special about the fact that we used alpha. You might, I mean, if you learned this before, you may have learned this.
Just for your information, sorry to interrupt.
You may have learned sine squared theta plus cosine squared theta equals 1. Doesn't make any difference. As long as the angle that you plug into both of these is the same, square the sine, square the cosine, add them together, it will always equal 1. Always. Okay? All right. Any questions? Yeah.
What do we use this for? Because it just equals 1, like.
I'm gonna show you. Funny you should ask. Funny you should ask.
Sorry.
Okay. This is called the fundamental trig identity. That's what this particular author calls it. Does anybody have a different name for it? Okay. Because we use the Pythagorean theorem to develop it, a lot of times we'll call it the Pythagorean identity. Okay? In fact, that's the way I learned it. You'll hear me refer to it most often as the Pythagorean identity. So you ought to know both. Fundamental trig identity, that's what it is. Another name for it, Pythagorean identity. So you can use those interchangeably. You need to memorize this. This will be on the test. If you know this on the test, you're going to write it down, you get a point for it. Okay? In fact, next week I'll show you a page of information. If you know that stuff, you're in great shape on the test. Okay? In fact, you'll have about 20% of the test just if you have stuff memorized. Okay, are there any questions? Okay, now, Kahala asked, what are we going to use this for if it always equals 1? Okay, well, here's an example of what we're going to use this for. This says, find the cosine of alpha if the sine of alpha is 5/13 and alpha is in quadrant 1. Now, I've got two different parts to this problem right here, so we're going to assume that alpha is in quadrant 1. So here's how we'd solve this, just using algebra and trigonometry, not drawing any pictures or anything like that. The sine of alpha is 5/13. What I don't know is I don't know the cosine of alpha. So wherever there's a sine of alpha, I'm going to put 5/13. So I'm going to put a 5/13 here. So 5/13 quantity squared, that's the sine of alpha, plus the cosine squared of alpha equals 1. Let's see, fractions generally aren't people's favorite numbers to work with, but if you're squaring things and stuff like that, they're actually not too bad. So if I square this, I get 25 over 169 plus the cosine squared of alpha. That should equal 1. If I need to know what the cosine of alpha is, I can get this, at least this term by itself, by moving the 25 1/69 to the other side. So this would leave me with the cosine squared of alpha is equal to 1 minus 25 over 169. These are just numbers. Let's go ahead and simplify that. 1 minus 25 1/69, well, that would be the same as 169 1/69 minus 25 1/69. So this is going to give me cosine squared of alpha is, well, let's see, 169 minus 25 is 144. Correct me if I'm wrong? Okay, so we've got 144 over 169. Now, this, I mean, algebraically, this just feels a little bit better. I need to know what the cosine of alpha is. Right now I have the cosine of alpha squared. How do I get the cosine of alpha all by itself? Take the square root. Now I'm going to take the square root and I'm going to end up with this. I'm going to end up with the cosine of alpha is equal to 12 over 13. Now I'm hoping that someone in here has just a little bit of heartburn over this last step right here. Jumping from this equation, just taking the square root of both sides and then saying that's the answer. If you were paying attention in your algebra class, you learned something when you're solving equations that have squares in them and you undo squaring something. David? There is a plus or a minus. There's a plus or a minus there. Whenever we undo squaring by taking a square root, we have to account for the fact that there could have been positive or negative, because when you square it, both of them turn out to be positive. Everybody good there? Okay, so my question for you is, which is it? Is it positive or is it negative? It's the positive one. Why do we know it's the positive one? We know it's in quadrant 1, therefore it's got to be the positive one. Okay, now the cool thing about this is, what if it's in quadrant 2? Don't answer out loud. Just think about this for a second. If we're in quadrant 1, both the x-coordinate or the cosine of the angle is going to be positive and the y-coordinate is positive. They're both going to be positive. Well, what if we're in quadrant 2? Okay. Then the x-coordinate or the cosine of that particular angle is going to be negative. So what's the answer on this one? Don't even have to do it. It's negative 12 over 13. We know that's the answer because the process would be the same. And there we go. Any questions? Okay. It's possible to just draw a picture of what this looks like. Like we could just draw the triangle in this quadrant here. Let me increase the size just slightly. It said that, let's see, the sine of alpha was 5/13, right? What side is the 5? It's the opposite side. What side is the 13? The hypotenuse, or the radius, right? So that's going to be 13, that's going to be 5. This would be 12. Went to the right and went up. So this would be positive 12, this would be positive 5, this would be 13. That works for quadrant 1. Look what happens in quadrant 2. Okay, now again, the sine of the angle is 5/13. Again, this is the opposite side, so this is going to be over here, or it's the y-coordinate. So this is going to be 5. Did we go up? Should it be positive? You bet. And that's 13. Radius, or the hypotenuse, is always positive. How big is this side? It's 12, and we went back, so it would be negative. So you can solve that problem doing it that way also. Are there any questions? Sure? Yeah.
We're going to need to know both ways to solve it.
Absolutely. They're both very valuable. Okay, and there are some problems on your assignment that say solve using an identity. This is how we find the answer to this one using an identity. This is how we draw a picture to solve it. Both of them are useful. You need to know both. Okay? If it doesn't specify which method they want you to use whichever one you want. Okay? Which one do most people like? Do they like the identity and solving it algebraically or drawing a picture? Most people like drawing a picture, but they're both useful. Okay? You need to know them both. Don't rely on just drawing a picture. Okay, any questions? Sure? Yeah.
When you're drawing a picture, I don't understand how you got a 12 without solving it with the actual.
So good question. Let's say we just drew a picture for this one. If we were doing this problem right here, so what we didn't know was this side here. So we would have said, let's make that x, and then let's use the Pythagorean theorem. So this is going to be x squared plus 5 squared equals 13 squared. So this is going to be x squared plus 25 equals 169. So that's x squared equals 144 once I subtract. Then I take the square root. Notice I run into the exact same issue. And really what we're doing is, remember, that's the Pythagorean identity. One way or another, you're going to use the Pythagorean theorem somehow. This is going to be a plus or minus 12. We then look up here and say, hey, I went back, I went to the left, so this would then be negative 12. Does that make sense? Okay. Anything else? Okay. So this is the part that I'm hoping is pretty easy. Well, we've been doing this for a while. We've been drawing pictures and considering which quadrant we're in and stuff like that. We've actually been doing these two things right here. We're now ready to attach some vocabulary to this. Okay? This particular author doesn't introduce these terms until later on. I think I've actually used these a couple times in class. Okay? So we're going to talk about a reference triangle. A reference triangle is this. It is a right triangle drawn in the correct quadrant using, which axis am I going to write here? Using the x-axis as one of the legs. So it's a right triangle drawn in the correct quadrant using the x-axis as one of the legs. The sides of the triangle must be correctly labeled with the correct lengths and the correct what? What did I make a big deal about here? With the correct sign. Okay? So if you're in the third quadrant, both the x and the y, both the adjacent side and the opposite side had better be negative because you went to the left and down. X would be negative, y would be negative. Okay? Third quadrant, back and down. We're right here. X is negative, y is negative. Adjacent and the opposite are negative. Any questions? Okay. So then the other vocabulary word for today is a reference angle. It is a positive. Reference angle is always going to be positive, and it's always going to be acute. It's a positive acute angle formed using the terminal side of an angle and what axis? X-axis. Again, always with the x-axis. Did I mention we always use the x-axis? I think I did. Please don't forget that. Don't try and draw right triangles for trigonometry with the y-axis. Okay, are there any questions? Okay, all right. So I'm hoping these problems are really easy. It says find the reference angle in radians or degrees. So let's draw this one right here. If you've got a 220 degree angle, notice that it's positive. So there's 90, there's 180. I'm going to be somewhere over here. Here's what the reference angle is. The reference angle is this guy right here. Remember, it's a positive acute angle formed with the terminal side, this guy right here, and the x-axis. So if this is 180 degrees right here, and altogether I've got 220, what's this little sliver right here? Oh, I heard some wrong answers in there somewhere, I think. What is it? 40. Take 180, or excuse me, take 220, subtract 180, and we end up with 40 degrees. That is our reference angle. Any questions? Okay, so this is negative 153. Negative 153, we want to find our reference angle. So there's negative 90. Negative 180 would be all the way over here, so we have to stop a little bit short. This is 153 degrees in the negative direction. I want to know, what is this little angle right here? What's that little sliver right there? Well, if the whole thing was 180 and I stopped short, 180, subtract 153, 27. Okay, the people that said 27 have it. There's our reference angle. Okay? It's always a positive acute angle formed with the terminal side of the angle and the x-axis. Good? Yeah.
So why is it always track 180 by
Okay, well, okay, so on this one we took 180 and we subtracted the angle, okay, since it was negative on this. On this one we did 220 minus 180, okay. It's always going to be compared to the x-axis, so it's either going to be 180 or 360, okay. Now, you can take the time to figure out a bunch of formulas, okay, and I think there are actually some in the textbook. I'd rather have you think about what's going on here. Remember, the reference angle is always between the x-axis and the terminal side of the angle. Okay? Does that answer your question? Okay. All right. So let's take a look at the next one. The next one is 3 pi fourths. So let's think about that for just a second. 3 pi fourths. And for some reason, all the ones that I've done so far are in quadrant 3. If this is 3 pi fourths, what's left for this little sliver right here? Pi fourths. Next one is 660. So let's figure out where that is. 660. Let's see, 360 all the way around. Another 300. 660 is going to put me about right there. So let's see, how would I figure out what that is? I didn't go 2 times around the circle. 2 times around the circle would be 720. I stopped a little bit short. I only had 660 degrees. What's the difference between the two of these? 60 degrees. Okay? So this is a 60-degree reference angle. We doing okay? Still with me? Okay, watch. What if this one weren't 660? What if it were, let's say it was 600. Let me change colors here. What if it was 600? Now to figure out this last one, I took 720 and I subtracted 660, right? That gave me my 60-degree answer right there. Can I do the same thing with this one? What's 720 minus 600? 120. What's wrong with that? Why is that not? Why is there no way on the planet this could be a reference angle?
It's obtuse.
It's obtuse. We need an acute angle. So what we'd want to recognize, if we were doing this problem here, where is 600 degrees? 360. Another 180 is 540, so it would be in quadrant 3. So I'd take, if this is 600 and this is 540, I'd take this one, subtract that one. Okay, again, it doesn't matter what order, you're going to make it positive anyway. This is going to be 60 degrees right here. Okay? All right. Any questions? Reference angle for 11 pi 12ths. Not a common angle that we typically use, but 11 pi 12ths. We'd think about, where is this located? And all I need is a positive acute angle formed with the x-axis. 11 pi 12ths. Let's think about this for just a second. 11 pi 12ths. 11 12ths. That's almost 1. That's almost 1 pi. Where is this? Quadrant 2. If I've used 11 pi 12ths here, what's left for this little sliver? Pi 12ths. There's my answer there. Okay? And you do the last one. Write down your answer. Consult with your neighbor. See if you got it right. Pi's over here, right? How big is that little angle if you tried to draw a triangle on that one? 0. Reference angle for that one is 0. Okay? All right, any questions? Yeah?
Is it 0 degrees?
It would be 0 because this is in radians. Okay? Good? Sure? Okay, let's take a look at the last part on this page. We've got these 4 problems to take a look at. Now, this shouldn't be difficult if you have the unit circle memorized. This says, find the exact value of each expression using reference angles. So here's what they want you to think about when you're doing this problem. 120 degrees is right here. Drop a line straight down. If that's 120 degrees, this right here is 60. If we've got those reference triangles memorized, or those special right triangles memorized like I asked you to, this would be 1, this would be radical 3 over 2, and this would be 1/2. And then I'm on a test, I'm thinking, you know, Laws said somebody was going to screw this up. Don't screw this up. That's going to be negative. Now, does that make a difference on this particular one? No, because we want the sine ratio. We want the sine of 120 degrees, so that would be the y coordinate. So the answer to this one is radical 3 over 2. Now, the only difference between this and what we've been doing is that you're kind of thinking of this little thing, and now it has a name. This is a reference triangle. This is a 60-degree reference angle, and once you know that's a 60-degree reference angle, then you use that. This has got to be the long side over here. That's going to be 1. This has to be the short leg over here, so that's going to be 1/2. Label all the sides according to what you know about a 30, 60, 90, and you're done. Good? Okay, next one, 11 pi 6. Cosine of 11 pi 6. Where is it? It's in this quadrant right here. We're thinking of this as our reference triangle, which means we've got a positive acute angle right here. So this is pi 6, which we remember as 30 degrees probably. That makes this 1/2, that makes this 1, and that makes this radical 3 over 2. Again, I've messed up on this one. It would be a big deal if this were a sine, but it's not, it's a cosine. The answer's right here, but you should make that one negative. Okay, are there any questions? Get a little uglier. Negative 17 pi 6. Here's how I like to think of this. I like to think of this as, well, this would be negative 2 and 5/6 of a pi. So this is going to be negative 2 all the way around the circle in the negative direction, and a negative 5 pi 6. So we're right here. Again, this little sliver right here is pi 6. This is 1, this is negative radical 3 over 2, and this is negative 1/2. And I want the sine ratio. What is the sine ratio on this one? Negative 1/2. There's our answer there. Okay? All right. Is that good? You get it? See how to do it? So cosine 135 wouldn't be a problem. In fact, you could just think about this for a second, and you don't even have to write anything if you know the unit circle really well. Negative 135, quadrant 3. How big is the reference angle? 45. How big are both the legs? Radical 2 over 2, and they're both negative. So the answer on this one is negative radical 2 over 2. Okay, any questions there? Okay, back side of the page. It says use reference angles to find the sine, cosine, tangent, so all 6 trig ratios for that particular value of theta. The one I'm going to focus on, this is actually out of your textbook. The one I'm going to focus on is this one right here. So we're going to do 23. So let's see, 2 pi thirds. It's test day. I know immediately where that is because I've spent a lot of time studying. If this angle is 2 pi thirds, that means my reference angle is pi thirds. That's 1, that's radical 3 over 2, and that's 1/2. That's got to be negative. So then I'm going to write down the sine of theta, the cosine of theta, and the tangent of theta. Sine and cosine are really easy. The sine is radical 3 over 2. The cosine is negative 1/2, and then I've got to think for just a second. Tangent. Tangent is the opposite over the adjacent, or the y over the y over the x. So let's see, if I do radical 3 over 2 over negative 1/2, first of all, my answer is going to be negative for sure. And if I flip this over, and that's 2 over 1, so I get radical 3. Okay, now there are those 3 answers. There are some identities that you have to have memorized for the test. I told you you've got to have these. How are these three trig functions related to these three trig functions? They're reciprocals, right? So to get the cosecant of theta, all I have to do is take the sine ratio and do what with it? Flip it over. 2 over radical 3. To get the secant ratio, because it's related to the cosine, I take the cosine and I flip it over. That one's easy. And to get the cotangent ratio, I'm going to flip this one over. That's negative 1 over radical 3. Now my question for you is, are those acceptable answers?
With no radicals.
They're okay. They're fine. Okay? Now, if you had a multiple choice question and those didn't show up, what would you have to do? You'd have to rationalize. That's going to put a radical 3 on the top here and change that 3 to a, or that radical 3 to a plain old 3. And this one's going to be negative radical 3 over 3. So you should be able to do that very quickly. Okay, but yeah, those are acceptable. Jeremy?
Are we doing 33?
No, we're doing 34. The one with a star by it, sorry. Good? Okay. I think you have to do those other ones as part of your assignment. Okay, next part. True or false, do not use a calculator. The sine of 210 degrees is the same as the sine of 30 degrees. Well, let's think about this. For 210 degrees, you'd be here. How big is the reference angle? 30 degrees. For 30 degrees, you're over here. How big is the reference angle for 30 degrees? 30 degrees. They're easy in the first quadrant. They're already positive and they're acute. Okay? So the question is the sine of 210 the same as the sine of 30 degrees? True or false? And can you explain why?
False.
Okay, the answer here is false. Does somebody want to tell us why this is false? Mackenzie?
Because the sine is the y coordinate, and in the third quadrant it's negative 1/2, and in the first quadrant it's positive.
Okay, here it's negative, here it's positive. That alone right there, that's enough to say that that's got to be false. Okay, and you could figure this one out. Well, gosh, we could do this one really quickly. Sine of 150 and sine of 30, are they the same? Yeah. Yes, they are, because 150 would be right here. They're both positive. They have the same reference angle, 30 degrees. Okay, and they're both above the x-axis, so the y-coordinate would be the same in both cases. Okay, any questions? Sure? All right, so let's take a look at some story problems that you've got from the assignment. I think one of these at least is on your assignment. 55 says motion of a spring. Would you read that question, think about it for just a second, and then see if you can answer part A and part B? So a lot of times people will look at story problems, they'll start reading, they'll get about, I'd say about the word is about enough to send a few people over the edge, and they just stop. They think, my gosh, this is a story problem, I can't solve this. Let's say you just ignored all the words and looked at the equation they gave you. And when I say ignore all the words, like ignore all of these words up here, just focus on this equation right here. And you can even ignore all the words in the first question and just look at the number they gave you. Now, if some algebra student walked in off the street and said, hey, you've got this equation right here and t equals 0, what do you think we ought to do? Plug it in. Just plug it in. So if I plug that in here, this is going to be x equals, this would be 4 times the sine of 0 plus 3 times the, cosine of 0. And because you've got these all memorized on the unit circle, the sine of 0 is 0. So 4 times 0 is 0. Cosine of 0 is 1. So this would be 3 times 1. So the answer on this one is 3. Where is it to start with? It says it's at 3. So now let's go back and read the problem. It says a weight suspended on a vertical spring as shown in the accompanying figure. The weight is set in motion and its position x on the vertical number line is in the figure is given by that function right here where t is measured in seconds. So they push or pull this weight. The spring kind of keeps it flopping up and down, and they start a stopwatch the minute they let it go. Okay. What did they do with it? Did they push it up, pull it down? What did they do? They pulled it down to 3, right? So they pull it down here. They start the stopwatch right when they let it go. So it's going to go up and then come back down and go up and come back down, just like that. Okay? And then it says find the exact position of the weight at t equals 5 pi fourths. Now we don't often measure seconds in pi, but that's the way it is here. So t equals 5 pi fourths. So what do you think we ought to do? Plug in 5 pi fourths. So x is going to be 4 times the sine of 5 pi fourths plus 3 times the cosine of 5 pi fourths. Okay, now there is something nice about this. If we're going to solve this problem, we could think about and we could actually draw
Brad, call the front office, please. Brad, call the front office.
5 pi fourths. 5 pi fourths is down here, right? 45 degree or pi fourths reference angle. That's 1, that's radical 2 over 2, that's radical 2 over 2, that's negative and that's negative. They both happen to be negative in this case. So this is going to be 4 times negative radical 2 over 2 plus 3 times negative radical 2 over 2. Let's see, what do we end up with here? Negative 4 radical 2 over 2 minus 3 radical 2 over 2. You might be tempted to simplify this right here. Why would that maybe not be a good idea on this particular one?
Because you can't simplify the other one.
Because you can't simplify the other one, and it might be better to write these together. So if I have negative 4 radical 2 minus 3 radical 2, that's negative 7 radical 2 over 2, and that's the answer to that particular problem right there. So if we were to convert that into a decimal that we actually knew how many seconds that was, so that's probably 4-ish or so, maybe about 4 seconds. After 4 seconds, it says the position is negative 7 radical 2 over 2. We could get a decimal for that, but my question for you is it above the point of equilibrium or below the point of equilibrium? It's going to be above, because in this particular coordinate system, above was negative. Any questions there? Okay. 58, I know for a fact this is on your assignment. I'm just going to get you started here. Okay. The hard part about this particular problem is this formula was actually in a previous column. I think it was 1 or 2 problems before that, but this is the formula we're going to need. Okay. It says a manufacturer of stop signs ships 100 signs in a circular drum. So here's the drum. They just stack the stop signs in there. It says use the formula from exercise 57. That's it right there. To find the radius of the inside of the circular drum, given that the length of an edge of the stop sign is 10 inches and the sign fits just shown as in the figure. Okay, round to the nearest hundredth. Okay, this right here stands for chord. Chord of a circle. Chord on a circle is a line that goes from one side to the other side. So this has actually 8 chords on it. Okay? A diameter is a special type of chord. It happens to go through the center. Okay? So how long is a chord on this problem right here? 2. C equals 10. We know we can plug that into the formula. What do you suppose R stands for? R stands for the radius. Does anybody know how to find the radius? Well, that's what it asks for. It asks us to find the radius, right? Okay. It says find the radius of the inside. What would theta equal? Okay, theta is, it's called a central angle. So how big is this angle right here? If there are 8 sides and they're all exactly the same, how big is the central angle? And how do you find it?
45.
It is 45. How do you find it?
360 divided by 8.
Take the 360 degrees all the way around the circle. If they're all equal, okay, we should have, I think I drew 7 there, but you get the idea. Divide that by 8. Theta is 45 degrees. Okay? So we're going to plug that in there. We're going to plug the C right there, and then we're going to solve for what R is. Okay, are there any questions? Sure? Okay, last thing, and then we're done. It says, what would happen if we took the fundamental trig identity, or the Pythagorean identity, and we divided both sides of the equation by, well, let's divide both sides by cosine squared alpha. So this would be sine squared alpha over cosine squared alpha. This would be cosine squared alpha over cosine squared alpha. And this would be 1 over cosine squared of alpha. Now, one of these is really easy to simplify. Cosines cancel out. So that makes this a 1. Anybody know what this is or this?
Is that tangent?
Very good. Okay, the way to think of this is the sine of alpha over the cosine of alpha, quantity squared. Remember, okay, we don't really square the trig function and then throw the angle in there. We throw the angle in, get the value, and then square it. So it actually looks like this. And this is an identity I asked you to have memorized for the test. This was in 1.1. Maybe it was in 1.2. Okay, this is the tangent. So this is tangent squared of alpha. And this would be 1 over cosine of alpha, quantity squared. What's 1 over the cosine? It is secant. So this is secant squared alpha. Okay? So there's another one. Okay. This right here is called the fundamental trig identity, or it's called the Pythagorean identity. This is an adjustment on the Pythagorean identity. It's another Pythagorean identity. Okay, this one's like it, and this is like a derivation of that. Okay, so it's an adjustment on that. So if you would, to finish the notes, if you'd find what happens when we divide by sine squared, and that's it. So think about those identities you're supposed to have memorized. This is a 1. What's cosine over sine? That's going to be cotangent squared of alpha. And what's 1 over sine? That's going to be cosecant squared of alpha. Okay, so there are 2 other Pythagorean identities. We'll use all of those. Okay. Any questions? Definitely have to have this one memorized. The Pythagorean identity, got to have that one. Okay, have a great day. Remember, review Monday, test on Wednesday. Where's the test going to be?